हेलो फ्रेंड्स, वेलकम यू ऑल हियर। यदि आपने अब तक हमारे यूट्यूब चैनल को सब्सक्राइब नहीं किया है तो अभी दबाएं सब्सक्राइब बटन को। इसके बगल में दिए गए बेल आइकन को दबाना न भूलें ताकि हमारे सारे नए वीडियोस आपको सबसे पहले देखने को मिलें। धन्यवाद।
Hello, my all students. After very long time, I am again starting making the video for my beloved students, and on the request of all the students, I am preparing the video of the chapter coordinate geometry, and students, it is for class 10th. In class 9th, you had studied about the location of any point on the plane, as well as if point coordinates are given, you can locate it on the Cartesian plane. Both things you had studied. So you can see, I would like to recall all the things once again. Just see. As you know, students, suppose there is a point on the coordinate system. This is called origin. It is x-axis and this one is y-axis. And suppose there is a point P. So for position of this point on the Cartesian plane, we are denoting it by suppose x1, y1. What it mean? It means when you are dropping the perpendicular from this one, this distance is x1, and now this perpendicular distance from this point P is y1. Now suppose another point is given. This point is Q and its coordinate is given x2, y2. So in the same method you can also locate these points. What is this distance? Distance of the point from y-axis is x coordinate, and you can see y coordinate of this point is distance from x-axis. Distance means perpendicular distances. It is y2. So if any point is given on this coordinate system, on that coordinate system you can locate these distances. Students, in class 10th you will study about the first thing, that is distance formula. See first its derivation. As you know, students, this coordinate geometry is given by a great mathematician, René Descartes. A French mathematician given the idea of this coordinate geometry very first time. With coordination of two branches of mathematics, one is algebra and another is geometry. So with the help of these two branches of mathematics, this branch of mathematics is derived. Its name is coordinate geometry, because with the coordination of algebra and geometry, this new branch is made by the René Descartes. Actually, there were some problems of algebra which is unsolved, as well as there were also some problem of geometry which was not solved by the mathematician of that time. So, very first time Rene Descartes studied total algebra as well as total geometry and given another idea. He divided the Euclidean plane, so divided into four parts. This one is called first quadrant, second quadrant, third quadrant and fourth quadrant. He divided with the two lines. One is horizontal line called as x-axis and vertical line called as y-axis. So student, you can see our main target, if any point is P, suppose A point is given and its coordinate is A, B. So one thing you can say, distance of this point A from y-axis is A and distance of this point A from x-axis is B. So you can see first coordinate is called as, this one is known as abscissa, and second y coordinate is called as ordinate. So by observation, if any point is given you can say distance of y-axis from point A is A unit and distance of this point A from x-axis is B and it is denoted by ordinate. So today students, you will study about the distance formula derivation. Also I will explain uses of the distance formula for proving collinearity and also finding the type of polygon, triangle, quadrilateral, square you can prove with the help of distance formula. Students, suppose there are 2 points in Cartesian plane. One point is P. We want to find the distance between these 2 points. For finding the distance between these 2 points, first we will drop one perpendiculars from one point P and from another point Q. Suppose these perpendiculars are PM and QN. One more perpendicular we will draw from point P on QN. It is making 90-degree angle, these three angles, and suppose this one is PL. Now students, as per position of the point P, this distance will be x1 and this PM will be y1. Now again you can write the distance of point Q from point L, that is y2, and you can see this distance is x2, ON is x2. Now you can see point P, x1, y1 and Q, x2, y2. These 2 points are given and we want to find the distance between these 2 points. So these 2 points are located on the plane and after location you can see about these distances. You can see PM is y1, OM is x1. Similarly, you can write about the x2. What is x2? x2 is ON and QN. You can write about the QN is y2. On this information, you can find some distances. You can see this point is L. You can see Pn will be equal to Pm and both are equal to y1. Now you can see this distance is y1. So for finding the distance QL, you can calculate the distance of point Q between Q and L. You can write Qn minus Ln. It means this distance is y2 minus y1. Similarly, we can find the value of length of PL. PL can be calculated as it is equal to Mn, and Mn can be calculated as On minus Om. It can be written as On minus Om. Now you can write here x2 minus x1. Now see here, we are knowing now for this right angle triangle, base is known, perpendicular is known, and one angle is 90 degree. So here you can apply the Pythagoras theorem. So you can see here this distance is x2 minus x1. This point is L, and this distance is y2 minus y1. You can see here in right triangle PLQ. In this right triangle, angle PLQ is 90 degree. You can apply the Pythagoras theorem. And after applying this theorem, you can write PQ is equal to, first we can write PQ square is equal to PL square plus QL square. Both distances are known. PL is x2 minus x1 whole square, and this one is y2 minus y1 whole square. In this way you can find the value of PQ as taking square root. So ultimately you will get the distance formula. Once more I would like to explain. Students, you can see, you can rewrite also. Since you have selected here point P and Q, suppose the coordinate of Q point is selected as x1 y1 and this is x2 y2. So you can see here this formula will be, also we can write it as x1 minus x2 whole square plus y1 minus y2 whole square. Any one we can use. Either you can use this one, it is called as distance formula, or you can also rewrite it as, and this is called as same distance we can calculate using this formula. PQ is equal to x1 minus x2 whole square plus y1 minus y2 whole square. So children, this is the distance formula. Now see how we will use this formula for solving our problems. If 2 points are given, we can calculate distance between them. So students, on the basis of distance formula, one exercise is there, 7.1, and its first question number 1 is given. What is this question? Find the distance between the following pair of points. It has 3 parts. now one by one part I would like to take. Suppose students, we are getting the solution of its first part. So consider this point is A, its coordinate 2, 3, and another point is B, its coordinates 4, 1. So you can write the value of x1, 2, y1, 3. Here x2 will be 4 and y2 will be 1. Now apply the distance formula. Distance formula as you had studied, x2 minus x1 whole square plus y2 minus y1 whole square. Putting the values here. So all the values I have written here. So you can copy from there. 4 minus 2. 4 minus 2 whole square plus y2. y2 is 1. y1 is 3 whole square. So now you can simplify it. You may see it as 4 minus 2, 2 square, plus this is again minus 2 whole square. So you can write here 4 plus 4, and if you will simplify it, you will get under root 8. Under root 8 can be written as 2 root 2 units. You don't forget to write the units. So student, this is the solution of its first part. Similarly, you can do the solution of second part. See how we will find. Suppose you are solving its second part. So one point is A, minus 5, 7, and another point is B, and it is minus 1, 3. So you can write here x1 minus 5, x2 is minus 1, y1 is 7, and y2 is 3. So you can again apply the formula, distance formula, that is x2 minus x1 whole square plus y2 minus y1 whole square. You can see it. Now substituting all the values to find our result. So x2 is minus 1 minus 5. So again you can use like this, plus y2. y2 is 3 minus y1 is 7 whole square. So you can see it is coming minus 1 plus 5. Minus 1 plus 5 whole square plus it is minus 4 square. Now in next line we can do 4 square plus minus 4 square. You can write its value 16 plus 16. That is under root 32. And this can be written as 16 to the 32 and square root of 16, 4. So 4 root 2 units its answer. So 2 parts completed. Now let us see about its third part. Let us see about the third part of this one. You can again note as see its solution. Third part is saying first A coordinate is AB and B coordinate is minus A minus B. Now you can note the values of x1 A, y1 is B, and from here x2 is minus A and y2 is minus B. Apply the distance formula now. You can see Now in this one I can apply this one also. You can write x1 minus x2. It is also distance formula. Y1 minus y2 whole square. Substituting these values now, x1 is a minus x2 is minus a, so minus a is also now whole square, plus y1 is b, and y2 is minus b. Now simplifying, it is a plus a whole square plus b whole square, means 2a whole square plus 2b whole square. Now squaring, so ultimately we will get 4a square plus 4b square. You can take common 4 and in bracket you will get a square plus b square. Now 4 has square root as 2, so its value will be a square plus b square unit. So students, all the parts of the question number 1 you can do like this. So in this way question number 1 completes. Question number 2. Find the distance between the points 0, 0 means origin and 36, 15. See, in the same manner we will solve this question. So this is O. Origin is 0, 0 and another point is, suppose A point is given 36, 15. So we want to find the distance OA. OA can be written as x2 minus x1 whole square plus y2 minus y1 whole square. Substituting the values, you can see this one is x1, this one is y1, this is x2 and it is y2. All the values are written here. Now substituting, under root x2, x2 means 36 minus 0 whole square plus 15 minus 0 whole square. Now you can write the simplify and find their squares. You can see square of this number 15 is 225 and square of 36, 6 6 is 36, carry 3, 9, 12. So square of 36 is 1296. Now we will add them. Addition 5 and 6, 1, carry 1, 12, carry 1, 5 and 1. If we will do the square root of this number, we will get its value. Now see how to find its square root. 1 5 2 1, taking this type pair. So 3 3s are 9. Now subtracting, so 6 2 1. 3 and 3 adding, so we are getting 6. Here you know 1 is there, so if we are taking 1 jar, so very small one, and again one number is there 9. 9 9 81 we are getting, so we can check with 9. 9 9 81, carry 8. 9 6 54, 54 and 8 62. So in this way we will get 0. So the distance between these points 39 units. Students, in the book one more thing is given. You can see there is written, can you now find the distance between the two towns A and B discussed in section 7.2. So in this book you will go through the paragraph 7.2 and see there are two towns A and B. You can also find the distance between them because you are knowing their coordinates. So rest part you will do yourself. Now come to the question number 3. Now students, see the question number 3. Determine if the points 1, 5, 2, 3 and minus 2, 1 are collinear. Now let us see its solution. Let these 3 points are, first point is A, point B is 2, 3 and point C is minus 2, 1. Now see here, if first of all you will find these values, one value of AB, you have to calculate the distance between AB. AB you can calculate 2 minus 1 whole square plus 3 minus 5 whole square. So you can see this value is 1 square plus minus 2 square. Now simplifying, so 1 plus 4, this value is under root 5. Come to see next value BC, you can calculate the distance between point B and C, minus 2 whole square, minus 2 whole square plus 1 minus 3 whole square. Now this is minus 4 whole square plus minus 2 whole square. You can see it is 16 and it is 4. It is coming under root 20. Now exact value we are not getting. You will get, see its value will be 2 point something. Just you can calculate how much it is coming. And its value will be 4 point something. Now one more value you can calculate, that is AC. AC, this is point A, this is C. Under root minus 2 minus 1 plus 1 minus 5. Simplifying now, it is minus 3 whole square, this is minus 4 whole square. Now see 9 plus 16, this is 16 and 9 25, this is 5. Now you can check, this is 2 point something and it is 4 point something. Here you can clearly write the value. You can easily understand it is 2 plus and it is 4 something. And if you will add 4 and 2, it is not never coming equal to 5. Here it is clear that AC is not equal to AB plus BC. You can write therefore 1 5 2 3 and minus 2 1 are not collinear. If distance between AB plus BC is coming equal to AC, then we can say these 3 points are collinear. Now let us see only when, suppose these 3 points ABC are given, their coordinates are known. So you check if AB plus BC is coming equal to AC, then A, B and C are collinear. otherwise no. So students, you can see condition of collinearity is this one. If 3 points are given, AB plus BC is coming equal to AC, then you can say 3 points are collinear. Now let us see question number 4. Check whether 5 minus 2, 6, 4 and 7 minus 2 are the vertices of an isosceles triangle. So first you consider these 3 points, 3 vertices A, B, C are given. Now calculate the distances. First you calculate the distance AB from here. 6 minus 5 whole square plus 4 minus 2 whole square. Now let us see. This is 1 square plus this is total 6 coming. You can see minus plus. So 4 plus 2, that is 6 square. So it is coming under root 1 plus 36, that is under root 37 units. Now another side BC. Similarly, you can also calculate the distance, length of the side BC. 7 minus 6 whole square plus minus 2 minus 4 whole square. Now this is 1 square plus minus 6 square. So you can get 1 plus 36. Again it is coming under root 37 units. It is coming under root 37 units. One more side is now left. AC. You can calculate the side AC under root 7 minus 5 whole square plus minus 2 minus 2 whole square. Now check how much it is coming. It is coming 2 square plus minus multiplication is plus, and here is minus 2, so it is coming 0 square, and it is coming, if you will take under root 4 plus 0, that is 2 units. What you are observing here? You can observe that here in triangle ABC, if there is a triangle ABC, so you can see AB is coming equal to BC. These two sides are coming equal, therefore 5 minus 2, 6, 4, and you can see 7 minus 2 are vertices of an isosceles triangle. So your answer will be S. Before here you can write a S. 5 minus 2, 6, 4 and 7 minus 2 are the vertices of an isosceles triangle proved. So this students, question number 4 now completes. Let us see question number 5. In a classroom, 4 friends are seated at the points A, B, C and D as shown in this figure. Champa and Chameli walk into the class, and after observing for a few minutes, Champa asked Chameli, Don't you think ABCD is a square? ABCD is a square. Chameli disagrees. Using distance formula, find which of them is correct. There are two friends, Champa and Chameli. Now let us check which one is correct. So for doing this question, first of all, we should write the coordinate of points A, B, C and D. So let us see the coordinate of point A is, you can see 3 and it is 4. So coordinate of point A is 3, 4. Coordinate of point B is, now let us see this position, 6 and 7. 6, 7. Coordinate of point C is, now see this position, 9 and 4. 9, 4. And you can also write the coordinate of point D. D is 6, 1. After finding these 4 coordinates, you can calculate the distances. First calculate the distance AB. AB is under root 6 minus 3 whole square plus 7 minus 4 whole square. It is 3 square. It is again 3 square. So 9 plus 9, that is 18. 18 can be written as 3 root 2 units. Again one more side, AB, BC. BC is, see this C point, 9 minus 6 whole square plus 4 minus 7 whole square. After simplification, we can get 3 square plus minus 3 square. Again you can see it is 9 plus 9 and its value is again 3 root 2 units. Now two more sides. You can see the length of CD. Let us see the length of CD. CD can be calculated as, this is D, this is C. So 6 minus 9. 6 minus 9 whole square plus 1 minus 4 whole square and its under root. Now you can see this one is coming minus 3 whole square plus minus 3 whole square. Again it is coming 9 plus 9 under root 18. Again you can rewrite it as, now one more side is left, AD. One side is AD. You can calculate the side AD. You can see A point is this, D point is this. So 6 minus 3. 6 minus 3 whole square plus 1 minus 4 whole square. Now it is 3 square plus minus 3 whole square. Again you can see it is under root 18. Its value is again. You may observe now all these distances. You can see AB is 3 root 2, BC is 3 root 2 units, and also CD is 3 root 2 units, AD is 3 root 2 units. Students, you can see if all the sides of a quadrilateral are equal, so it may be rhombus. For being the square, their diagonal should be also equal. So see, check the length of the diagonal. By observation you can also see. You can see it is 1 unit and it is 7 unit. So length of diagonal BD is 6 unit. Now the length of diagonal AC, it is 9 and it is 3. So 9 minus 3, length of diagonal is again 6 unit. So since here it is told, find the using distance formula we have to prove. So we can also calculate the length of diagonal AC. See how we will calculate using distance formula. By observation we can say, but in question it is told using distance formula we have to show. So now see that AC, distance AC, 9 minus 3, 9 minus 3 whole square plus 4 minus 4, 4 minus 4 whole square. You can write it as, this one is 6 square plus 0 square, it is coming 6 units. One more diagonal is BD. Also we can see the length BD. Where is B? This is B, this is D. So BD we can write 6 minus 6 whole square plus 1 minus 7 whole square. You can see it is coming 0 square plus minus 6 square. If you will simplify, you will again get 6 units. Now see the explanation. Since AB is equal to BC is equal to ABBC is equal to AD is equal to CD, all these are equal, and diagonals AC is equal to BD. Therefore, it implies that quadrilateral ABCD is a square. Now you can see who is correct. You can decide yourself which one, Champa is correct or Chameli is correct. So decide yourself. So this is question number 5. It is completed. Students, you can see question number 6. Question number 6 is saying there are 4 points are given of a quadrilateral and you have to check what type of quadrilateral is given. So I am going to read the question number 6. Name the type of quadrilateral formed, if any, by the following points and give reason for your answer. Means if a quadrilateral is not forming, you can also write no, because quadrilateral is not possible. And now you must know the condition of a type of quadrilaterals. You can see one condition I discussed in question number 5, and that condition is for square. For square you have to prove all the sides are equal and diagonals are also equal. Now I would like to tell you for proving rhombus. For proving the quadrilateral is rhombus, it is uses of distance formula. Distance formula is only one. Either you write in this form, or you can also use the distance formula in this form: x1 minus x2 whole square plus y1 minus y2 whole square. Now see the use of this one. First use, you can prove the collinearity of 3 points. Given 3 points are collinear or not. Second use, first use you had seen collinear. So you can see first use of the distance formula for finding the distance between any given 2 points whose coordinates are given. And first, now see, you can also check the collinearity. Is 3 points are collinear or not? Student, one thing you learn, these 3 points are, if not collinear, they can form triangle. If these 3 points are collinear, they will not form a triangle. So type of quadrilateral, you can see first. Suppose I am giving you conditions. Suppose there is a quadrilateral and we want to prove it is a rectangle. For proving it as rectangle, if 4 coordinates A, B, C, D are given, you know the condition opposite sides are equal. So I am giving one by one condition for a rectangle. You can see the condition for rectangle. You can prove AB is equal to CD, BC is equal to AD, and diagonals should also equal, and diagonals BD and AC both are equal. So if these 3 conditions are satisfying, that quadrilateral will become a rectangle. And for a square, you can see all sides are equal and diagonals are also equal. So condition is again A, B, C, D. Here coordinates of all these 4 vertices are given. So for square, all the sides AB is equal to BC is equal to CD is equal to AD, all sides are equal, and diagonal BD is equal to diagonal AC. So if this condition is satisfying, that quadrilateral will become a square. Now for rectangle, you can see for a rhombus, you can see the rhombus condition of being rhombus. All sides are equal but their diagonals are not equal. See, for condition for being a quadrilateral as rhombus, you can see all sides are equal and their diagonals should not be equal. AC is not equal to BD. This condition, if satisfying, then you can say the given quadrilateral is a rhombus. One more thing is there, parallelogram. If parallelogram is given and its all 4 points coordinates are given, so you can learn the condition for a parallelogram. Condition is that opposite sides are equal. Means AB is equal to CD, BC is equal to AD, and the diagonals BC and AC are equal. So if this condition is satisfying, we can say the quadrilateral is a parallelogram. So these are the condition. On the basis of this one, you can solve the question number 6. So students, as you are knowing the formula for distance, so here you have to calculate all these distances. In question number 6, you have to calculate all the side length as well as diagonal in each and every case. There are 3 cases given, so you can do it, find the distances and decide according to your situation. And one more thing you can see, sometimes it is happening, the quadrilateral is not forming if 4 points are given. What is happening? Suppose the quadrilateral is, one diagonal is suppose A, B, suppose point is given somewhere else, A, B, C, D. So here quadrilateral is not possible. You can see the length of the 2 sides. You know that the quadrilateral is combination of 2 triangles. If 2 triangles are combined like this, so it is forming a quadrilateral. But sometimes this below triangle is forming and above triangle is not forming. So sometimes such conditions are occurring. In such cases, the quadrilateral is not possible. So you will also check it. The sum of 2 sides will be always greater than the third side. Here what is happening? Here AD plus CD is equal to diagonal AC. Therefore these 3 points are collinear. So only they are forming a triangle, not a quadrilateral. So in question number 6, second part, it is existing that it is not forming a quadrilateral. You can check yourself. And now come to see the question number 7. Question number 7 is saying find the point on the x-axis which is equidistant from 2, -5 and -2, 9. First thing, student, you must know any point lying on the x-axis is of the form x0. So let us see, the point is on the x-axis is x0 and there are 2 points which are equidistant from it. First point is A. Consider, let point on x-axis be x0 and points A 2, 5 and B -2, 9 are equidistant. Equidistant from this, suppose this point is P, equidistant from point P x0. What it says? The coordinate of point A is 2 minus 5 and coordinate of point B is minus 2, 9. Now in this question it is given these two distances are equal. So you can see here, we can apply here, since this is point P. Point P is equidistant from point A and B. It means PA is equal to PB. Or you can write PA square is equal to PB square. Now applying the distance formula for finding the value of PA, you can write 2 minus x whole square plus minus 5 minus 0 whole square is equal to, you can see I squared here, so we will not use this under root sign because I already squared it. So PB, you can see PB is minus 2 minus x whole square plus 9 minus 0 whole square. Now we can simplify it to get the value of x. Now squaring it, its square is 4 minus 4x plus x square plus it is minus 5 and square is 25. Now you can see square of this one, its square will be 4 plus 4x plus x square plus square of 9 is 81. Now you can see x square is cancelled both sides, and now simplifying rest terms. So here 4x we can take that side. First thing, 4 is cancelled, this beginning 4 is also cancelled. So 4x I am taking that side and 4x is already here. So 4x plus 4x. Now 81 I am taking right hand side. So 25 minus 81. You can see 8x is equal to minus, subtracting 1, 11 minus 5, 6, 7 minus 2, that is 5. Now the value of x you can calculate now here. You can see the value of x is minus 56 upon 8. X is equal to how much ja? You can see 7 ja. Now you can write your answer in sentence. Point on x-axis is minus 7, 0, which is equidistant from point A and B. So this is your required answer. So you may simplify or solve the question number 7 like this. Question number 8. Find the value of y for which the distance between the points P 2 minus 3 and Q 10y is 10 units. So see its solution. You take the point P and write its coordinate. Point Q 10y, point P 2 minus 3, and distance between these 2 points is given 10 units. This distance is given. So you can apply the distance formula here. You can see PQ is used here. Under root x2 minus x1 whole square plus y2 minus y1 whole square. And from these 2 points I have written here, x1 is 2, y1 is minus 3, x2 is 10, y2 is y. Now putting all the values and like this you can simplify one by one line. After substituting the values you can get ultimately, you can see after this line we are squaring both the sides. We will get 100 is equal to 64 plus y plus 3 whole square. After simplification you will get ultimately y square plus 6y minus 27 is equal to 0. Now you can split the middle term. This is minus 27 and it is 6. So 9 3s are 27. So plus 9y and minus 3y. You can split this middle term like this. So taking two terms together, y plus 9 and minus 3 taking common, so y minus plus, so you can see taking minus as common, so here in bracket positive sign will be there, y plus 9 and y minus 3 is equal to 0. You can see one value here, y will give minus 9 and one value of y is 3. So there are two answers. The value, find the value of y. So the answer is 2. Either the value of y is minus 9 or the value of y is 3. So these two answers are coming. This is the solution of question number 8. Question number 9. If Q01 is equidistant from point P 5 minus 3 and R x 6, find the values of x. Also find the distance QR and PR. You can see it may be possible that the two values are coming of x. So now you can see we can here locate point Q and its coordinate is 0 1 and 2 points are there P and R. One point is P whose coordinates 5 minus 3 and R is another point whose coordinates 6 x 6. So in this question it is also given these two distances are equal. Now we will find here, since it is given that PQ is equal to QR, this condition is given. Now putting the value, you can write it as again in the form of whole square, so that we can not use this radical sign. Now substituting the value PQ 0 minus 5 whole square plus 1 minus 3 whole square is equal to QR. QR you can write x minus 0 whole square plus 6 minus 1 whole square. So simplifying it, so it will become 25 and here it is totally 4 because it is plus 3 and 1 4. 4 square is 16. Now here square x square and plus here it is coming 5 and 5 square is 25. So you can see 25 cancelled out. So x square is equal to 16. So value of x is plus minus under root 16. So the value of x is coming 4. Positive and negative both. So two values of x is coming. The values of x is equal to 4 and minus 4. Two values are here. Now you can get the value of what is asked here. QR. You can calculate QR. Two values of QR you can get. Where is Q? Now in place you can see Q point is here 0, 1 and R point is now in place of X you can write 4, 6. So one value you can get with this one. Simplifying 4 minus 0 whole square plus 6 minus 1 whole square. It is coming 4 square plus 5 square. Now simplifying it, so it will give you 16 plus 25. 16 plus 25 is under root 41. So this is 41 units. Now one more value you can get of QR. One more value of QR you can get when the value of X is minus 4. So Q point is same 0, 1 and you can write here point R is now minus 4, 6. So again you can get the same distance QR. So simplifying it, so minus 4 minus 0 whole square plus 6 minus 1 whole square. Ultimately you will get same value, no change, 4 square plus 5 square. If you will simplify, it will again under root 41 units. So in both the cases the value is same. Now one more distance PR you can calculate using same method. Now PR will be calculated as under root. These 2 points are given PR. We want to calculate this distance. In place of X we are putting 4. 4 minus 5 whole square plus 6 minus 3 whole square. So simplifying it we can get 4, this is minus 1 square plus it is 9 square. So 1 plus 81 and the answer is coming under root 82 units. So students, in this way question number 9 completes only one question, 10 is left. You can now see the solution of question number 10. Question number 10, it is last question of the exercise 7.1. Find a relation between X and Y such that the point XY is equidistant from points. These 2 points are given 3, 6 and minus 3, 4. So same way we will consider this point. One point is XY which is given here. Suppose this point is P whose coordinate is given, and given these 2 points A and B. So A point coordinate is given 3, 6 and point B coordinate is given minus 3, 4. And these, for being these two distances equidistant because it is given, so you can see again apply the same formula. You write here, since PA is equal to PB, or you can write PA square is equal to PB square. This you can apply now. X minus 3 whole square plus y minus 6 whole square is equal to PB. X minus 3 whole square plus y minus 4 whole square we can simplify it. Now x square minus 6x plus 9 plus y square minus 12y plus 36 is equal to squaring of this one. It is x plus 3, and x plus 3 whole square we can write it as x square plus 6x plus 9, and squaring of this one y square minus 8y plus 16. Now simplifying, so see here x square cancel, we can see y square cancel, 9 to 9 cancel, and see anything else? No. Now here we are getting minus 6x minus 12y plus 36 is equal to 6x minus 8y plus 16. You can now simplify taking all these terms that side. So what we will get? 6x plus 6x minus 8y, and it will, when transposed, it will become positive y, and here plus 16 already present, and minus 36 here this side, and we are not writing equal to 0 this side, but we are writing the 0 in this side. So simplifying, it is 12x minus, no minus because it will be 12 minus 8 is 4, positive 4y, and here minus 36 minus 16 minus 20 is equal to 0. Now each and every term you can see divisible by 4. So you can write 4 3s are 12, 4 1s are 4, and it is minus 5. So this relation is required relation, because in the question it is given find a relation. So this relation is obtained, and this is your answer. Students, I hope you like this video very much, and it is last question of the exercise 7.1, and I know you like my videos. In the demand of my beloved students, I made this video after very long time. I hope you will like most. Don't forget to share with your other friends. Thank you very much.